Hi there and welcome back. In the last video we'll be talking about Minterm and Maxterm. So now it's time to make some example. So how about solving something with Minterm and Maxterm? So let's suppose that we have our function, our Boolean function, which is like this. F of x, y, z is equal to not y times x plus not z. So what if we are asked to find the canonic form for this expression? So we're interested in finding the canonic form for this expression. Now a way to do that, first of all, is to write the truth table. And then we can, from that, we can actually use either Minterm or Maxterm. So how about we do that? So x, y, z, and result, which is actually going to be our output. So let's do this. Right, so I have 0, 0, 0, 0, 0, 1, 0, 1, 0. I'm just counting right now. 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and then 1, 1, 1. Right. Gonna make this one a little bit longer. There we go. So, how about finding the result? Well, in order to find the result, I basically gotta plug those number back into our function. So, let's do that, shall we? So if we plug y into this function, we get y naught, so 0 naught, times x, which is 0, plus z naught, which is 0 naught. So 0 naught is 1 times 0, which is 0, plus 0 naught is 1. So you get 1 times 0 plus 1 is 1. 1 times 1 is 1. So the output of this first line is, oops, wrong color, is 1. Okay, so let's do the other second line. 0, 0, 1. So with 0, 0, 1, we have y naught, so 0 naught, times x, which is 0, plus z naught, which is 1 naught. So we have 0 naught, which is 1, times 0, 0, plus 1 naught, which is 0. So we have 1 times 0 plus 0, which is 0. So 1 times 0 is actually 0. So we got a bfud 0 here. Now let's go on. Right, so 0, 1, 0. So if we plug 1 here, we get 1 naught times x, which is 0, so 0, plus z naught, which is 0, so 0 naught. So we have 1 naught, which is 0, times 0, plus 0 naught, which is 1. So we get 0 times 0 plus 1 is 1, so 1 times 0 is still going to be 0. So I get 0 again. And again, we go on. With 0, 1, 1, so we plug in 1. We get 1 naught times x, which is 0, plus z naught, which is 1, so 1 naught. So you get 1 naught is 0 times 0, plus 1 naught is 0, So 0 times 0 plus 0 is 0, and therefore we get 0. Now, we must continue. So 1, 0, 0, we get y naught, so 0 naught, times x plus y naught, plus, I'm sorry, z naught, so x is 1, so 1 plus z naught, so 0 naught. So 0 naught is 1 times 1 plus 0 naught, which is 1. Therefore, we have 1 times 1 plus 1 is 1, so times 1 is indeed 1. So you get a 1. And again, we go on with this 101. So if we plug 0 in y, we get 0 naught times x is 1, so 1 plus z is 0, sorry, 1, so 1 naught. So 0 naught is actually 1 times 1 plus 1 naught is 0, so we get 1 times 1 plus 0 is 1, 1 times 1 is indeed 1. And again, we got the last two. So 1, 1, 0, so y is 1, so you get 1 naught times x is 1, so 1 plus z naught, which is 0, so plus 0 naught. So you get 1 naught, which is 0, times 1 plus 0 naught, which is 1. So you get 0 times 1 plus 1 is 1. So 0 times 1 is sadly 0. Now we get 1, 1, 1. So if we plug 1, 1, 1 in, we get y naught, so 1 naught times x, which is 1, plus z naught, which is 1, so 1 naught. So 1 naught is 0 times 1 plus 1 naught is 0. So you get 0 times 1 plus 0 is 1, so 0 times 1 is 0, and we got 0 again. Now, we can use both the Minterm and the Maxterm. So I'm gonna do both of them. First, I'm gonna start with the Minterm. So Minterm, well, now let me just use green. Green is fine. So Minterm. So the Minterms, when we look at the Minterms, we're basically going to look at those which have the result of 1. So if I'm gonna just, I'm just basically gonna write the truth table back real quick. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, whoops, and 1, 1, 1. And so the result that we copy from here is 1, 0, 0, 0, 1. Did I get it right? 1, 0, 0, 0. Oh, I got 1, 0, 1, 1, 1, 0, 0, 1, 0, 1. Oh, 1, 1, 0, and 1, 1, 1. Yeah, that was a mistake. So 1, 1, and then 0, 0. Right, so we have the truth table back. Now we're going to use the Minterms. So basically we're going to look at all the members that have 1 in the result. So this one is a 1. And we are basically going to write our expression based on the value of x, y, and z. So x is actually 0, therefore we write not x times y is 0, so we write not y, and z is 0, so we write not z. Then we have this member here, which has an output of 1. We're basically gonna ignore those because they have an output of 0. So here we have an output of 1, and x is indeed 1, so we basically write x times y is 0, so we write y naught, times z, which is 0, so we write z naught. And again, we have yet another member with a 1. So x is 1, we write x times y is 0, so we write not y, times z, so z is 1, so we write z. Now those products are the one that you are gonna use to get the sum of product representation, because minterms are actually expressed in a sum of product representation. So we can say that those products are the ones that are gonna give me the canonic form sum of products, so SP. And the canonic form for this is basically f of x, y, z equal to, well, those added together. So not x times not y times not z plus x times not y times not z plus x times not y times z. And this is the representation with the minterms. Now, what if we wanna do that with the Maxterm? Well, we can do that. It's fine. We can do this very same thing. So Maxterm. So we do that with the Maxterm. You can say still x, y, z, result. So I'm just copy this one more time real quick. So 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 0, and 1, 1, 1, 0. All right, so let me just go here with the camera. Okay, so basically with the Maxterm representation, now I'm just gonna be interested in the ones that have as a result they have 0. So I'm just gonna ignore those that have 1. I'm gonna focus on those who have 0 as a result. And I'm basically gonna do the opposite. So I'm gonna focus on whether the result is 0 and whether x, y, and z are actually 0. So x is indeed 0, so I write x plus y because it's 0 plus not z because it's 1. And I'm going to do the same for this line here. So x plus not y because it's a 1 plus z because it's 0. And again, x is 0, so we write x plus not y, not z because they are both 1. So not y, plus not z. And then the last two are those two. So in this case, we have x, which is 1, and y, which is 1. So we write not x plus not y. And then we have z, which is 0, y plus z. And lastly, we have 1, 1, 1. So not x plus not y plus not z. Of course, I'm using the sum because Maxterms are actually given by a, all the sum in a product of sum. So we can actually say that those sum are the ones that are gonna give me the canonic form PS. So this is a product of sum. So in this case, my canonic form f of x, y, z is going to be the product of all those sum. So we have x plus y plus not z times x plus not y plus z times x plus not y plus not z times not x plus not y plus z times not x plus not y plus not z. So again, you can basically find the canonic form of expression by just making the truth table based on the entry that you get by putting the entry into your expression, your function. And from that, you can basically get the result of the truth table, and you can use and get the representation either by using the Minterms or the Maxterm. If you use the Minterm, then you're going to be focusing on the term that actually give you 1 as a result, and you're going to use the sum of product representation by basically checking whether x, y, and z are 1. If they are, you write x, y, and z. If they're not, you write their complement, so not x, not y, and not z. Once you have done that for all the entries that have the result of 1, then you basically have the sum of product representation, because you just have to add all those three together. So you get the first expression plus the second expression plus the third expression. In the same way, you can do that with the Maxterm. In this case, you're only going to be interested in the terms, the entries that actually give you 0 as a result. And you're going to check whether x, y, and z are actually 0. If they are, then you're going to write x, y, and z. If they're not, you're going to write their complement. So not x, not y, not z. And the Maxterm use the product of sum representation. So you're going to add them together. And then once you get the expression, you got to multiply all those together. So you got the final expression, which is this first one, times the second one, times the third one, times the fourth one, times the fifth one. So yeah, this is pretty much it about Minterm and Maxterm, but I'm gonna make one more example. So stay tuned for the next video.